Good evening, class. We are looking at exam 2 review. Covering from section 3.1 to 3.8, ultimately most of chapter 3. The first part, we're going to cover the first three sections, 3.1 to 3.3. So chapter 3, differentiation rules, 3.1, derivatives of polynomial and exponential functions, 3.2, the product and quotient rules, 3.3, derivatives of trigonometric functions. This is the part that we are going to cover for now. Well, as you recall, here's the definition of differentiation. dy dx is the limit of delta y over delta x as delta x approaches 0, or f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. In the previous exam, we must have used that one in every aspect. Now we can take the easy way out and use formulas. The derivative of x is 1. The derivative of c times f of x, you can take the c out. The derivative of f of x plus minus g of x, that means the derivative of the sum is sum of the derivatives. The derivative of the difference is the difference of the derivatives. Couple of limits that are useful. Limit of sine theta over theta as theta approaches 0 is 1. Limit of cosine theta minus 1 over theta as theta approaches 0 is 0. Definition of E is limit of 1 plus 1 over n to the power of n as n approaches infinity. That's one way to write it. Or E is a number such that the limit of e to the power of h minus 1 over h as h approaches 0 equals 1. Then we have the most basic formulas that we are going to basically use today, and then others are coming our way. The derivative of a constant is 0. The derivative of x to the power of n is nx to the power of n minus 1. That's called the power rule. As a result of that, the derivative of kx is k. K is a number. The derivative of sine is cosine. Cosine is negative sine. Tangent is secant squared. Cotangent is negative cosecant squared. Secant is secant tan x. Cosecant is minus cosecant x cotangent x. There are more formulas coming up. I'll show you, such as the product and quotient rules. The chain rule, this one, for example, is the extended power rule, exponential functions. Composite functions or the chain rule. Logs, natural logs, and logs in general, and inverse trigonometric functions. As you can see, we have quite a bunch of formulas, and you need to get comfortable with those, but we will get there, and we will look at examples to make sure we are comfortable with those. Now, let's get started with the easiest one. First, we are going to cover the first few sections. This covers all of them. Example 1, differentiate y equals x to the power of 1000. It's important to know which formula we are using. We are using the power rule. The power rule says if you want to take the derivative of x to the power of n, n becomes the coefficient. That means it sits in front, and the exponent goes down by 1. So in this case, 1000 sits in front, and x to the power of 999, because 1000 minus 1 is 999. Y equals 3r squared. How do we deal with that? In the same manner, this coefficient remains. So if you want y prime is 3. Now r squared, 2r to the power of 2 minus 1, or 6r. So what I want to mention are other notations. Y prime, dy dr. Why dy dr? Because r is the independent variable. Also, we could say ddr of 3r squared, okay? So it's important to understand various notations. The answer is, of course, 6O. Now, what happens when we have a bunch of terms, when we have a polynomial? We look at each term and we take the derivative. So f prime of x, the first one becomes 8, x to the power of 7. So what happened? 8 becomes the coefficient and the exponent goes down by 1. Plus 12 times 5, 60, x to the power of 4. So what happens? 12 remains, 5 becomes a coefficient, the product of 12 and 5 is 60, and the exponent 5 goes down by 1. Negative 4 and 4, their product is negative 16, x cubed. So the two get multiplied and 4 goes down by 1. 10 times 3, 30, x squared. Minus 6x is minus 6, and any number results in 0. And we are done. That is the final answer. Example 2, f of x is x times square root of x plus 5. In order to get this ready for using the power rule, you have to change the square root of x. What is square root of x? X to the power of 1/2. We are going to distribute the x, and bear in mind that x has exponent 1. And using this rule, when we multiply these two, we are multiplying these two and say x to the power of 1 plus 1/2. So it becomes x to the power of 3/2, 5x minus 2. So what you're looking at is an algebraic step. Now, 3/2 sits in front. X to the power of 3/2 minus 1, or 1/2, and plus 5. So again, the first one, 3/2 is the coefficient, and then 3/2 minus 1. So just this one, I want to make sure we are comfortable with that, becomes 3/2 x to the power of 3/2 minus 1. And of course, x to the power of 1/2, we put it back in the same format, becomes 3/2 square root of x plus 5. What about part B? The weights given, we cannot use the power rule, so we have to make an algebraic step such that it becomes ready for the power rule. This part uses the quotient rule of exponents, and it's 2/9 x to the power of 5 minus 9. And this is x to the power of 5 minus 9. So that's the first thing we want to do. Now to differentiate, f prime is 2/9 times -4 x to the power of -4 minus 1 is negative 8 over 9 x to the power of negative 5, or negative 8 over 9 x to the power of 5. Remember, your final answer cannot have a negative power, negative exponent. What is the derivative of pi squared? Well, you have to recognize this as a number. Pi squared e 2.5, 1/5, 10,000. Makes no difference. The derivative of any number, any constant, is 0. So recognize that. The answer is 0. So we looked at some power rules. Now we want to look at the product rule. Now, there is a warm-up example here where we are going to differentiate. We are not going to simplify, just to emphasize the importance of the first step, which is basically differentiation. The rest is algebra. Now, some of you have seen the product and quotient rules. This is the shorthand notation, fg, that means f of x times g of x. You want to differentiate it as f prime g plus g prime f. If you have learned it already in a different format, it's fine. But why am I giving you this format? Because this will help with the quotient rule. The quotient rule, f over g prime, uses the same thing in the numerator and changes the plus to minus. So f prime g minus g prime f over g squared. So we are going to use the product rule. So according to the product rule here, everybody, f times, by the way, you can distribute and use the power. But let's stick with the product rule. We need, so write the formula next to you from the memory, not from the notes, not from the PowerPoints, from the memory, and just follow. Here's f. F prime would be 4x cubed minus 6x squared. So again, 4 sits in front, x to the power of 4 minus 1. Minus 2 times 3 is minus 6, x to the power of 3 minus 1. F prime g. So just put the g, the second parenthesis next to it. Minus, plus, my apologies, plus g prime, 6x minus 5. That's 3 times 2, x to the power of 2 minus 1, minus 5, and times f, the first parentheses, x to the power of 4, minus 2x cubed, minus 7. Bear in mind, this is not finished, but this is the only calculus step. Everything else is algebra. Here's another warm-up example. We want to differentiate y equals x squared times sine x. We notice y is the product of two functions, x squared and sine x. So I'm going to put a raised dot in between to emphasize the fact that we are dealing with the product rule, everybody. So I'm going to call the first function f, namely x squared, and second function g, namely sine x. And I'm going to use the product rule. F prime is 2x times the g sine x plus g prime, the derivative of sine is cosine x. The derivative of sine x is cosine x times f, the first function is x squared. And we're going to rewrite this by simply putting x squared in front because it's awkward to have this in this format. Someone may be under the assumption that means cosine of x cubed. I've seen that done, which is wrong. So you must put the x squared in front. So with a couple of warm-up examples to make a point that the product rule is very simple. One step is that, and then there are other steps involved. All right, so y is 5x times 3x minus 2 to the power of 4. And I want to remind you of the power rule, the product rule, the quotient rule, and this is part of the chain rule, the extended power rule. So if you look at the basic power rule, nx to the power of n minus 1. In this case, you have a function g of x to the power of n. So similar to that n, similar to that x to the power of n minus 1 becomes g of x to the power of n minus 1. But when you go back here, the derivative of x is 1, everybody. So times 1, we don't write that, but the derivative of g of x is no longer 1, it's g prime of x, you have to write. So when you come across a case like that, there are two ways to do that. I'm going to look at both methodologies. One way is to say, okay, 5 is a coefficient. It's going to carry over up to the end. And you just keep it outside by using brackets. And that's absolutely perfect. One way is, and the more involved this number, that means if it's a large number, like 5,000, or if it's a fraction, like 2/3, or if it's a decimal, it's a good practice to do that. Now it's a small number, it's not a big deal. That's why I want to show you both. So number one, notice that this is the product of this piece and this piece. So I'm going to put a raised dot in between. And I'm going to treat this as one function, this one as the second. So in essence, you are looking at f g. So we are going to go with the product rule first. F prime 5 times g, the second piece, which is the parenthesis to the power of 4, 3x minus 2 to the power of 4, plus g prime. Now, let's look at the g prime, and it follows the extended power. Let's see how that works. So plus, we want to write g prime. First, we have the number 4. Then we have g of x to the power of n minus 1. We have 3x minus 2 to the power of 4 minus 1, or 3x minus 2 cubed. Then g prime. What is the derivative inside the parentheses? 3. And this entire thing, 4 times 3x minus 2 cubed times 3, this entire thing is g prime. And now let's go back here. G prime what? F. The f is 5x times 5x. I'm going to write at top of it so you see what happened. This is f prime g plus g prime f. I'm gonna put an asterisk next to it. Done with calculus. Now we are going to use our algebraic techniques to finish the job. This piece 4 and 3 and 5, their product is 60. 4 times 3, 12 times 5 is 60. So you write 60x, 3x minus 2 cubed. So just this part simplifies to this one, okay? You don't have to do that because really you have to factor. I just want to make sure that you are clear as to what's happening. Now, this is the piece that we have. I'm going to erase my work so it becomes clear. We have this piece and this piece. So we are going to factor it. What's in common between 60 and 5? 5 is in common. 3x minus 2 to the power of 4 versus 3x minus 2 cubed. 3x minus 2 cubed is in common. So what's in common? 5 times 3x minus 2 cubed. You divide this piece by it, 5 goes away, and this creates just one of them, 3x minus 2. What about this one? If you divide by it, everything goes away except 60x divided by 5 gives you 12x because 3x minus 2 cubed goes away completely, right? Divide this one by 5, you get 12x. As you can see, 12 and 3, they add up to 15. Therefore, you have 15x. This is the final answer, everybody. Now, I'm going to emphasize that there was one step of calculus here, right here. Okay? Then 1, 2, 3, 4, minimum 4 steps of algebra. So when you get this one done, we are done with the course. Then it goes back to your prior knowledge of mathematics. Now, what I was mentioning about this number 5, I want to go over that, and that is the following. If this number is either very large or it's involved, it's a decimal, it's a fraction, you do the following. You put a bracket here. You keep the 5 outside the bracket. See, it creates that 5. And you work with the rest of it. It's x times the parenthesis quantity to the power of 4. So you put the 5. This one is 1 times 3x minus 2 to the power of 4. Then plus, this sits in front, 4 times 3x minus 2 cubed times the derivative of the inside 3 times x. So if you can follow that, this part inside the brackets is f prime g plus g prime f. And if you finish it, you get exactly the same. Now again, right now makes not much of a difference, but it does make a difference when this number is involved. Y equals 1 over 7 x squared minus x to the power of 4. Now we are getting to the territory dealing with the quotient rule. The question is, should we use the quotient rule? And the answer is, if you don't have to, no. But if you have to, you try to avoid it, you probably make a mistake. In this case, all you have to do, bring this up and make it -4, and now use the power rule on that, or better yet, the extended power rule. Therefore, you don't have to use the quotient rule. So if that's the case, y prime is -4. I'm looking at this one, -4. Then I have the function to the power of n minus 1. So this parenthesis to the power of -4 minus 1, which makes it -5. And then finally, g prime is the derivative of the inside. The derivative of the inside is 14x minus 1. So you have a fraction bar, -4 and 14x minus 1. Their product is at top. This piece, which has a negative exponent, goes down, becomes with a positive exponent. Again, we are looking at the quotient rule, the warm-up example. We're not going to simplify. And you may recall that the numerator was F, the bottom was G when we did the product rule. So we are going to stick with that. So if I am giving this question, I'm going to write this from the memory and I'm going to follow that. So the top is the F function, the bottom is the G function. So y prime, a huge fraction bar with f prime being 4x cubed minus 6x squared times g, so times the bottom, minus g prime. So g prime is this, differentiate 6x minus 5 times f times the top over g squared. So just put the bottom in a parenthesis and square. And I hope you realize the numerator, if you go back to the warm-up example for the product rule, was exactly like that, except it had a plus sign here. That's why I believe it makes it easier to memorize. If g prime is f prime g plus g prime f over g prime is f prime g minus g prime f over g squared, a shorthand notation. F of x is 10x squared minus 7x cubed over x squared. So I have to use the quotient rule. In this case, I had to, and if I tried to avoid it, it probably doesn't work or it makes it more difficult. This one I don't have to. I make up two fractions. Divide, you get 10. The divide, you get minus 7x. So make up two fractions. The derivative is simply negative 7. Find the limit of sine 3x sine 5x over x squared as x approaches 0, reminding you of a couple of important limit laws. This limit of sine theta over theta as theta approaches 0 equals 1. I have the proof. If you want, you can look at the lecture notes. The limit of cosine theta minus 1 over theta as theta approaches 0 equals. So we notice everything is sine at the bottom, at the top and the bottom involves x. So we have to make it look like either this or that. And it's clear we can make it look like that. But bear in mind, if you have an argument, you can't change the argument of sine, okay? 3x is 3x, 5x is 5x, they cannot be changed. So what we do, we make up two fractions, one of them sine 3x over x, one of them sine 5x over x. And since this is 3x, 3 is missing here. I can put a 3 here and 3 there. This one 5 is missing, I do the same. So I'm looking at this piece and this piece separately. And please understand what happens as x goes to 0, so does 3x. So does 5x. Now, it's very important that when you look at this part, you can take this 3 out. When you look at this one, you can take the 5 out. But when you look at this one and this one and this one must be identical. That's why I changed this x to 3x. This one and this one and this one must be identical, and it is. Now, you can leave it like that, or for the first one, for example, you can say 3 limit as theta approaches 0 of sine theta over theta. You do the same thing with the second one. In other words, in this case, you are letting theta represent 3x. You don't have to do that. Why not? Because you're writing 3x here, 3x here, and 3x here. So this is 3, this is 5, their product is 50. So that's pretty straightforward, everyone. I hope everybody is okay with that. We are going to move on. All right, so what happens here? That's what we are interested to find. In a similar manner, we're going to move on here. We don't have anything like this here, but it seems to me that it's similar to this somehow. So why don't we give the top and the bottom a denominator of theta? Please understand, we are dividing the top by theta, the bottom by theta. We are not changing anything. And so we look at the limit for the top and the bottom separately. Now this we have is 0, and this we have is 1. 0 over 1 is 0. Then I want to go back to something and tell you, if you plug in class, cosine of 0 is 1. 1 minus 1 is 0. Sine of 0 is 0. So if you plug in, you get 0 over 0. I want you to know that. If you plug in, you get 0 over 0. The same thing for part A, you get 0 over 0. The limit of cosecant x sine of sine x as x approaches 0. Notice, think about this as the argument of sine theta. Think about it in that manner. Think about this like theta because it's the argument of sine. So we're going to take the cosecant down and change it into sine because, as you know, cosecant theta is 1 over sine theta. And so when x approaches 0, that means sine x approaches 0. And look at this. This and this and this are identical. You can even change them to theta. As x approaches 0, so does sine x. So you can say sine of theta. So it's very straightforward, everybody. Okay. I hope you find it straightforward. And the answer is therefore 1. The limit of sine x squared over x as x approaches 0. Again, we want to try to use what we are given in this. When you look at this argument, for you to use this one, and this one, and this one must be identical. So you multiply this by x. If you multiply this one by x, you have to multiply the top by x. Okay? So multiply the top and the bottom by x. So the denominator is x squared. So you're going to write the limit of x as x approaches 0, and the limit of sine x squared over x squared as x squared approaches 0. Please understand, when x goes to 0, so does x squared. That's important to understand. Please understand we are separating this into x times sine x squared over x squared. I hope you can see that. So therefore, this piece, limit of x as x approaches 0, this piece, limit of sine x squared over x squared, as x approaches 0, which can be x squared approaching 0. So this becomes 0, this becomes 1, their product is 0. We want to differentiate y equals 1 plus sine x over x plus cosine x. And we recognize this as f over g, and therefore we are going to use the quotient rule. Again, if I'm given this, I'm going to write this as f over g, and I'm going to write this formula, and I'm going to follow that. So y prime is a huge fraction bar. F prime, the derivative of 1 is 0. Sine is cosine x. F prime g, just put the denominator gx plus cosine x here. That's all. You don't have to do anything. Minus g prime. The derivative of the bottom, x gives you 1, plus cosine gives you minus sine, times f, the top, 1 plus sine x. And the bottom is g squared. Just write the bottom in a parenthesis and square it. You don't have to do anything, everybody. So when we distribute here, we get x cosine x. We put the x in front, plus cosine squared. What about this too? A minus b, a plus b gives you a squared minus b squared, or 1 minus sine squared. Now, a bunch of identities from trigonometry known as Pythagorean identities. Sine squared plus cosine squared equals 1. Tan squared plus 1 is secant squared. 1 plus cotangent squared equals cosecant squared. So just to discuss the first one. When you have this one, then you should recognize that sine squared is 1 minus cosine squared. Cosine squared is 1 minus sine squared. Sine x is plus minus the square root of 1 minus sine squared. You don't have to write any of them. It should be obvious, okay? And of course, plus minus, you make a decision based on the quadrant. And so 1 minus sine squared can be replaced with cosine squared, and we do so. Cosine squared and negative sine squared cancel each other, and practically we are done. We just write whatever is left. Y prime is x cosine x over x plus cosine x quantity squared. We are done. So that's pretty straightforward, everybody. We are going to move on. Uh, as we come across questions from that involve something such as geometry or trigonometry, I'll cover that for you, and I hope it's coming. All right, let's look at this one. We said the derivative of tangent is secant squared. We're going to look at the proof. By the way, for the sine, there's a lot of trigonometry involved, trigonometry and algebra and geometry. You can find it in my lecture notes. The rest of them, cosine, we can follow the sine, and the rest of them, we can do it using some sort of a rule, mostly the quotient rule. So we want to prove this, and we know tangent is sine over cosine, and I'm going to remind you tan x is sine over cosine or 1 over cotangent x. Cotangent x is cosine over sine or 1 over tan. Secant x is 1 over cosine and cosecant is 1 over sine. We need to know all of these identities, class. And so we are going to use the quotient rule. Therefore, we're going to give it a name f over g. So what happens? We follow this quotient rule, f prime g minus g prime f over g squared. So f prime, the derivative of sine, so y prime becomes f prime g. So f prime is cosine x times g, the denominator is cosine x, minus g prime, the derivative of cosine is negative sine. So minus negative sine times f, the numerator is sine x, over g squared, the bottom, cosine x squared. Again, just to make sure we understand what's happening, this is f prime g minus g prime f. As you can see, the top is cosine squared plus sine squared, which adds up to 1. If 1 over cosine is secant x, then 1 over cosine squared must be secant squared. So the derivative of tan x is secant squared. We just proved that. The derivative of secant x is secant x tan x, and we want to prove that. Well, we said secant x is 1 over cosine x, which means f over g, and we are going to use the quotient rule, everybody. So we are going to go with f prime g minus g prime f over g squared, where f prime 1 becomes 0, any number, the derivative is 0, times g, which is cosine x, minus g prime, the derivative of g, cosine is negative sine, times f, the numerator is 1, over g squared. Just put the denominator here and square it. Obviously, their product is 0, and their product is positive sine x. We want to make it look like that. As you recall from trigonometry, we would make certain changes. For example, this one, we're going to represent them as two fractions, 1 over cosine times sine over cosine. One over cosine is secant x. Sine over cosine is tan x. So the product of secant x and tan x, and that's the final answer, everybody. So we proved the derivative of secant x is secant x times tan x. I highly recommend you do the same thing for cotangent and cosecant as practice. Prove the derivative of cotangent is negative cosecant squared. y equals 1 minus secant x over tan x. We notice this as f over g, therefore the quotient rule can be used. We put y prime equals a huge fraction bar, f prime. Let's look at the derivative of the numerator. 1 gives you 0, minus secant gives you secant x tan x. So negative secant x tan x times g times tan x minus g prime, the derivative of tan x is secant squared. So minus secant squared times f with the parentheses, the numerator 1 minus secant x over tan x and square it because it's g squared. So again, I think it's pretty straightforward. Just write the formula from your memory and follow that. Now, let me put an asterisk to it. Again, I want to mention that this is it. You're done with calculus. Now we are going to do more steps, algebra, geometry, trigonometry, you name it. So what do we get here? We get negative secant x tan squared. What do we get here? Minus secant squared plus secant cubed. So that's the numerator. We notice all of them involve secant x. So we can take out secant x. And if we do so, what happens? Again, the denominator is not being touched. The numerator, we are factoring secant x. This gives us negative tan squared minus secant x plus secant squared. So that's what we get. One of Pythagorean identities tells us that 1 plus tan squared is secant squared. So if I move the tan squared to the right, that means secant squared minus tan squared equals 1. Notice this one and this one, secant squared minus tan squared equals 1. Replace that. There's nothing else we can do to simplify it further. We are done. Y equals cosine x over 1 minus sine x. We notice a fractional expression, we call it f over g, and we follow the quotient rule again. Y prime is f prime g minus g prime f over g squared. So y prime is f prime minus sine x times g, just put this in a parenthesis next to it, minus g prime. What is the derivative of 1? 0. What is the derivative of minus sine x? It's minus cosine x because the derivative of sine is positive cosine. So this gives you negative cosine x times f, the numerator is cosine x. And just write the denominator and square that. So put it in a parentheses and square it. That's all you have to do. Here's the asterisk indicating we are done with calculus. Minus sine x plus sine squared plus cosine squared. Don't touch the denominator. These two add up to 1. So you're looking at 1 minus sine x in the numerator. Please understand I want to rewrite this because I don't want anyone to make a mistake. Understand the numerator is 1 minus sine x. And the denominator is the same thing, squared. So you can take this one out and take one of the exponent out, and the final answer, y prime is 1 over 1 minus sine x. So I hope you see the importance of prior knowledge of mathematics, trigonometry, geometry, and so on. Find an equation of a tangent line to the graph of the function y equals e to the power of x cosine x at 0. To find an equation of a line, you need a pair, it's given. You need the slope. We are going to differentiate. So we are going to find y prime. The first thing we noticed is the product of e to the power of x and cosine x. We put a raised dot in between and we put fg at top to say, okay, we are going to use the product. So y prime is f prime, the derivative of e to the power of x is itself. E to the power of x. F prime g times cosine x plus g prime, the derivative of cosine x is negative sine x plus the parentheses negative sine x times f e to the power of x. And that is the extent of the calculus step, and we are completely done with calculus. We factor e to the power of x out. When we plug in 0, that becomes the slope. M is y prime of 0. Y 0 because that's the x coordinate, which is e to the power of 0 times cosine of 0 minus sine of 0, which is 1 times 1 minus 0, which makes it 1. Instead of using y minus y1 equals m times x minus x of 1, I'm going to use y equals mx plus b because not only the slope is given, this indicates b equals 1 because 0, 1 is the y-intercept. So m is 1, b is 1. The answer is y equals 1x plus 1 or simply x plus 1. That's the final answer for this question. Please understand, this was the only calculus step. Find the points for which the tangent lines are horizontal. When the function is given and you're looking to find the tangent lines, you have to take the derivative. So you find f prime of x, and of course you use the power rule, 3x squared minus 6x. If you're looking for tangent lines to be horizontal, that means you want f prime to be 0. Horizontal means set this one equal to 0. Factor the 3x out. 3x times x minus 2. This means x is 0. This means x is 2. Now, sometimes this is the end of their story. That's all they want. Sometimes they want you to give them the pairs just to be on the safe side. I'm going to give you the pairs. For 0, if you plug in, you get 5. So 0 gives you the pair 0, comma 5. If you plug in 2, then you get 2 cubed minus 3 times 2 squared plus 5. They add up to 1, and the pair is 2, comma 1 as the final answer.